Welcome back to our chemistry series. In the last episode, we introduced you to the enchanting world of chemistry, the science that helps us understand the ways of our universe. Today, we're going deeper into the basic of matter, atoms, molecules, and compounds. This is a fundamental topic in chemistry, so let's take our time to explore it thoroughly. Let's start with atom. Atoms are incredibly small, so small that millions of them could fit on the head of a pin. But don't let their size fool you. Atoms are incredibly powerful. They're like the tiny Lego bricks of the universe. When you start putting them together, they can create everything from simple molecules like water to the complex structures of life itself. Every atom consists of three main parts: protons, neutrons, and electrons. The number of protons in an atom's nucleus defines what element it is. For instance, hydrogen atoms have 1 proton, oxygen atoms have 8, and carbon atoms have 6. The periodic table of elements organizes all known elements by the number of protons in their atoms, which is called the atomic number. So, when you look at the periodic table, you're seeing a map of all the different kinds of atoms that can exist. We will be going into that in future videos. Now, let's zoom in even further. The protons and neutrons are packed tightly together in the nucleus at the center of the atom. This nucleus is incredibly dense. It contains nearly all of the atom's mass. Surrounding the nucleus are the electrons, which are much lighter and move around in what's called the electron cloud. These electrons occupy different energy levels, or shells, and the way they're arranged determines how atoms interact with one another. Electrons are fascinating because they don't just sit still, they move around the nucleus in regions of space called orbitals. These orbitals have different shapes and sizes, and each one can hold a certain number of electrons. The first energy level can hold up to 2 electrons, the second up to 8, and so on. This arrangement of electrons is what gives each element its unique chemical properties. When atoms interact, they form molecules, which are groups of 2 or more atoms bonded together. A simple example is the water molecule, H2O, where 2 hydrogen atoms bond with 1 oxygen atom. This bond is possible because the atoms share electrons, creating a stable arrangement. But not all bonds are the same. Some atoms share electrons equally, while others don't. This leads to different types of chemical bonds, like covalent bonds, where atoms share electrons, and ionic bonds, where one atom donates an electron to another. Let's take a closer look at some common molecules. Water is a polar molecule, meaning the electrons are not shared equally between the hydrogen and oxygen atoms, giving the molecule a slight electrical charge. On the other hand, carbon dioxide is a nonpolar molecule because the electrons are shared more equally. These differences in bonding have significant effects on the properties of the substances. For instance, the polarity of water is why it's such a good solvent. It can dissolve many different substances. Compounds are substances made from 2 or more different elements that are chemically bonded together. A well-known example is sodium chloride, or table salt. Sodium is a metal, and chlorine is a gas, but when they bond, they form a stable, edible compound. This bond happens because sodium donates one of its electrons to chlorine, resulting in an ionic bond. The properties of compounds are usually very different from the elements that make them up. Compounds are all around us. For instance, water is a compound made from hydrogen and oxygen, while sugar is made from carbon, hydrogen, and oxygen. But not everything we encounter is a pure compound. Many materials are mixtures, where different substances are combined but not chemically bonded. A salad, for example, is a mixture. You can still see and separate the individual ingredients. Understanding the difference between elements, compounds, and mixtures is key to mastering chemistry. Now that we've covered atoms, molecules, and compounds, let's briefly talk about how these particles come together in different states of matter. The state of a substance, whether it's solid, liquid, or gas, depends on how its molecules are arranged and how much energy they have. In a solid, the molecules are tightly packed and only vibrate in place. In a liquid, they're more loosely packed and can move around each other. In a gas, the molecules are far apart and move freely. These states are all about energy and molecular interactions, which we'll explore in more detail in future episodes. Understanding these states is crucial because many chemical reactions involve a change in state. For example, when water boils, it changes from a liquid to a gas, but it's still water. However, if we were to chemically break down water into its elements, we'd end up with hydrogen gas and oxygen gas, an entirely different scenario. This difference between physical changes, like changing states, and chemical changes, like breaking bonds, is fundamental in chemistry. To sum it all up, chemistry is about understanding how tiny particles, atoms, come together to form the substances that make up our world. These atoms bond to form molecules, and when different elements combine, we get compounds with entirely new properties. The way these particles interact and change states under different conditions is the essence of chemistry. In our next episode, we'll dive deeper into these states of matter and explore the fantastic world of chemical reactions. Thanks for sticking with us through this deep dive into the world of chemistry. If you found this episode helpful, please give it a thumbs up, share it with your friends, and don't forget to subscribe so you won't miss our upcoming episodes. Next time, we'll be exploring the states of matter and how they can change from one to another. Until then, keep learning.